My name is Jonathan. Hi. This is my first time to Philadelphia in, I counted it at about 18 years. The last time I was here was for a computer programming competition in high school, which was a lot of fun to remember. And now I'm back at a tech conference, so that's super fun. My job is a director of engineering at an automated testing cloud service called Sauce Labs. Some of you might have heard of us before. We let people run automated functional tests on mobile and web applications at a very high scale and speed. What I'm here to talk about today is my experience with re-architecting a pretty large Node.js application. Some things I learned along the way and some misconceptions that I realized that I and my team had along the way that led to certain mistakes, but also led to a lot of learning. So hopefully that will be valuable for us in the future and for you guys right now. I had to use this kind of stock photo of San Francisco, I guess, because it's like the branding that I have to use when I give presentations as a Sauce Labs employee. But I'm going to try and work it into the talk because it kind of puts me in the mind of a very large application, right? You've got a lot of complexity, you've got things of different shapes and sizes. All the lights going around here kind of put you in the mind of speed and organization and stability, and really at a distance at night, a city is very beautiful and organized looking. So I guess we probably want our apps to look and feel like the impression that we get from this kind of photo, but a lot of times I wonder if what we actually feel when we kind of really know our app really well and we dig into the guts of it is something more like this. Sometimes the complexity doesn't do very well. Sometimes it's a little more overwhelming than beautiful. Sometimes things are kind of leaning against each other and crumbling over and all that. So all that to say, architecture is pretty important, and that's a big part of what this talk is about. But what exactly am I talking about? I'm not just a director of engineering at Sauce Labs. I'm also the project lead for an open source mobile automation tool called Appium. Anyone heard of Appium before? Okay, cool. Appium is kind of the spiritual successor to Selenium, which is a web automation tool. Anyone used Selenium before? Okay, yeah, so Appium is basically the same thing, but for native and hybrid and mobile web applications on Android, iOS devices. So it's kind of like Selenium for a broader set of automatable things. Appium allows you to kind of write scripts like Selenium in any programming language and lets you control mobile apps from a UI perspective, just like a user would, which is really valuable for functional testing. The video that's going on right now shows Appium or a script really, which is up there in the top left, written in Python. It's exercising the UI of this Photos app as part of a functional test. And as I said before, Appium supports Android, iOS, and as of a couple weeks ago, actually Windows desktop apps, which is kind of fun. And of course, it's all open source. It's a fairly large project. This is a screenshot of our GitHub page that I took a couple days ago. So, fair number of commits and stars and forks and things like that. A lot of releases. It says we have 146 contributors, which is pretty cool. I was going to say we had over 120 different unique contributors. So I guess it's gone up even since I last paid attention. And a core team spread across multiple organizations, Sauce Labs, other places. And we've been working pretty hard on it for about 3.5 years now. So this is kind of one of my hats, and it's the main thing that I'm going to be talking about in terms of Node.js application architecture. But as I said before, my kind of day job is engineering director at Sauce Labs. I manage a group of amazing developers, and we provide this cloud service that's built on top of Selenium and Appium, where the kind of idea is that instead of running tests one at a time on your local machine, you can run them at some kind of massive scale, maybe hundreds, maybe even thousands of tests at a time on a cloud service. And so this video is trying to illustrate that by loading up 4 tests, because that's about as many as I could fit on my desktop while still being able to see the kind of video of the tests in progress, and we're just automating a contacts app on Android here. So that's a general idea, but I'm not going to talk about this today. I'm going to talk about Appium and some stuff we did with it recently. So once upon a time, this is mostly going to be a story, so I hope that it's valuable in that format, and we can talk about key takeaways and whatnot at the end. But the story begins with Appium, where it's written in Node.js. We picked Node for a bunch of reasons 3.5 years ago when we started work on this. One of the main reasons was because Node is great for writing servers. Node is great for writing HTTP servers, TCP servers, all kinds of servers. But Appium is first and foremost an HTTP server. And it talks to clients. That's the way that we can support test scripts being written in any language, is we have this HTTP protocol that is spoken between the client and the server. So you can create a library in any language. Appium manages subprocesses and in some cases even speaks HTTP to them as well. So Node's really great at that, and we got a bunch of awesome stuff for free because we made that decision. We also like Node because we like JavaScript, and we knew that we were going to be putting this project out into a very diverse community of users and developers, and we wanted contributions from a lot of people, not just people who are experts in Java or people who are experts in Python or whatever. So we figured JavaScript is kind of the lingua franca of software development these days, so it was a good choice. Going back to the city analogy, let's say a year after we started development on Appium, things were going great. Kind of felt it was like this beautiful city. It was, reasonably complex, but pretty small. We were relatively organized, had a lot of people helping, a lot of new contributors coming on board. The community was excited about what we were doing, getting good feedback. And then the project over the years kept growing and growing. Like many of your applications, we kept adding features bit by bit, maybe skipping some refactors along the way that we probably should have taken care of. But our community was exploding. We were spending all of our time managing issues on GitHub, reviewing pull requests, going out and talking about Appium at conferences and whatnot. And meanwhile, Android and iOS keep releasing new versions of their operating systems. Every time they do that, we've got to change a bunch of stuff in Appium to support it. And we begin to build kind of hacks on top of hacks to keep things functioning and rolling forward. So pretty soon things start to feel like this, which is, we talked about before, not how you really want things to feel. So it started to get a little unwieldy. And what do I mean by that? Let me give you a couple examples. I subtitled this slide like, what happens when you try to patch up all the broken things in mobile automation? And the reason I'm saying this is because I want to, maybe unfairly, because they're not here to defend themselves, but cast some of the blame on Apple and Google for developing automation technologies which are pretty flaky, pretty poorly supported, often don't work, and all the rest. And so it fell to us, to the Appium community, to try and smooth over all of those differences and all those problems. But it's not Apple or Google's fault that we made a bunch of the mistakes that we did, so I can only blame them so much. The truth is that our code base had grown organically, as code bases do, in a variety of styles, using a variety of architectural patterns. Some people would do one thing, some people would do another, and being an open source project that really valued inclusivity and getting people started, we would often merge a pull request that wasn't quite standard because we wanted that person to contribute, and then we said, well, we'll go back and fix it later, and then never did. So here's some of the specific things that we identified as problems when we went to try and ask ourselves what was wrong. A pretty common thing, our code wasn't modular enough. Sometimes it was too modular. It was modular in the wrong ways, I guess. We were using the kind of traditional version of JavaScript that was in residence 3.5 years ago, and actually didn't work out as well as we thought, even though JavaScript was the lingua franca of software development. We were using pretty specific kind of Node.js JavaScript, and it turned out to be hard for new contributors to get started, so it's kind of opposite of what we wanted. A lot of the confusion for newcomers to the project had to do with asynchronous programming. Who loves callbacks? Okay, well, so yeah, callbacks. As I said before, one of the main responsibilities that Appium had was to manage subprocesses. So we manage ADB, we manage Xcode build, we manage instruments, we manage UI Automator on Android, we manage all these kind of subprocesses to like set up the automation environments. Sometimes these are long-lived, sometimes they're not, sometimes we care about the output, sometimes we don't. So we had a lot of very complex custom subprocess management stuff that was getting kind of crazy all over the place. We had this crazy coupling between requests from the clients and then our business logic way down in the stack. We would actually pass a node request object, in some cases down like 5 layers deep in our application. And then we never knew who was actually responsible for handling that. Sometimes multiple things tried to handle it with disastrous consequences. Same thing with errors. We never knew exactly whether we were handling an error in the right place. Sometimes we handled it in multiple places, which we didn't need to do, and sometimes we didn't handle it at all, which caused weird silent bugs all over the place. And then being an open source project, we had specific needs, like the need for someone who's new to the project and wants to contribute to come in and get up to speed quickly without having to spend days learning the architecture of the project. If this was some kind of internal company project, we could ramp someone up over 5 or 6 weeks. But we want someone who has discovered a bug to be able to know exactly where that bug is caused, to be able to fix it without having to get the whole project inside their heads. And we were failing at that, so we wanted to fix it. So a couple specific examples. When it comes to modularity, this is kind of a very simplified overview of the architecture that we had before we started looking at these problems. We have our kind of client, who's a test script of some kind, our main HTTP interface, which listens to the client, and then we have our different what we call automation backends, our things that we're trying to automate on iOS and Android. And we have these bits of software that we call drivers, which are the thing that interfaces between Appium and the fundamental automation technology on iOS or Android. This is an okay picture, but what you're not seeing here is that the drivers were conceptually very similar, but solved the same problems in very different ways. So there was a lot of code that could have been standardized, could have been conceptually factored out, and made to serve both drivers that was in fact scattered all around inside each driver. Other times, code that kind of conceptually belonged together was strewn about in different files. I talked about client request management, for example. That stuff was spread all throughout the architecture, and it should have been just in one place. So that's what I mean by kind of some of the modularity problems. Callbacks, I probably don't need to go through this. This isn't actual code from Appium, but it's actually less gnarly than a lot of the actual code that we did have. Really, we're not doing something that's very complex here, but because of the nature of asynchronous programming, and when we care about not doing one step in the control flow until the previous step has finished, when you mix all those things together, doing something simple can end up with this monstrosity here, which is, you can't just look at it and know what the logic is. You have to really dig in and understand it. So as I said, it's a trumped up example, but it's actually easier to understand than a lot of stuff that we actually did have in Appium. So this kind of thing isn't really great for gaining contributors to your open source project, right? Who wants to spend their Saturday afternoon understanding this? There's also a source of bugs even for people who knew what they were doing. It happened all the time. So sub-process management, I mentioned that we did a lot of stuff with this. This is another kind of fake example that mimics a lot of the kind of thing that we do in Appium, where we use the spawn function from one of the Node core libraries. And what this function is doing, I called it board tail. It's basically calling the tail command as a sub-process, but then after a certain amount of time, stopping. So it's like it's getting bored, right? So it's basically saying, tell me this file and print out the output until a certain amount of time has elapsed. kind of stupid example, but it's the kind of thing that we do a lot of in Appium. And you can just see there's a ton of boilerplate here. There's a ton of things to remember to listen to in terms of event handlers. If you don't do some of those things, you'll have weird errors, and it's just kind of a pain. So in short, we felt a bit like, the sorcerer's apprentice here. We started to feel like every time we wanted to make a change to our application, we had to, carry these huge buckets of water up and down huge flights of stairs and not spill them and not trip and fall on our faces and all that. And it was getting more and more arduous. So we sat down and thought, what can we do to solve these problems? And so we came up with a list of solutions. This was kind of the beginning of our re-architecture. We actually had the luxury of a fair amount of time and a number of developers who were committed to working with us on this. So we decided to do a complete rewrite from the ground up. We branched our code and changed all of our old JavaScript into ES 2015, which, if you're not a JavaScript person, is like the new hotness of the language. And there are a couple of things that were particularly useful for us. Some of these features that I mentioned here kind of took care of some of the basic gotchas. I'm also not mentioning function binding, but I guess that's part of arrow functions, and that was a huge thing as well. So that kind of helped with a lot of the inapproachability for new contributors. But far and away, the biggest thing which helped was getting rid of callbacks and moving to async await, which is an even newer part of the language. It's not even officially a standard yet, but which for our particular use case was so valuable, it was worth it to adopt this kind of cutting edge, sort of untested language feature, and it's been absolutely amazing for us. We wrote a wrapper around Node's child process library. I called it teen process because it's a slightly more grown-up version of Node's child process, and that really helped cut out a huge source of bugs for us. But most significantly and most effortfully in terms of time and concentration, we reorganized all our code, and in the process decided to follow the Node convention of splitting our application up into a bunch of tiny modules, which you guys have probably heard that idea a number of times. And I'm going to call this the philosophy of micromodules. I don't know if anyone else has called it that before, but it kind of sounds like microservices, and I think it's a good way of getting at this idea of having lots of small modules around. So what did some of these solutions look like specifically? Well, just briefly, moving from callbacks to async await got us from what's on the left side, what I showed you guys earlier, to what's on the right side, which even if you've never seen async await before, you can kind of just omit those strange syntactic constructions, and if you just look at this, you can now actually see the logic that we're going for. You can see the control flow that we're attempting to follow here. You can actually just read it like you would normally be able to read code. So you can imagine that as a new contributor to the project, maybe you're not super familiar with async await, but you can at least see what's going on. And if you just kind of write code that's like the code that's around you, you're actually going to be pretty successful. We've already seen this to be true. This teen process library that I was talking about enabled us to get rid of a lot of boilerplate and allow a library to handle some of the common error scenarios for us in terms of sub-process management. So we were able to cut down by about 50% a lot of our sub-process management code. So it's a cool library. I recommend checking it out. And of course, it uses async await both in terms of how we wrote it and in terms of how you can import and use it. Or of course, it works with promises as well. Okay, so now let's talk about the modularity bit, since this was one of our major efforts as part of the rewrite. And this is what it looked like before, if you remember. And then we changed it to something that was more like this, where essentially we factored out a lot of that common conceptual logic for the drivers that I was telling you about, and kind of made them these vertical layers here, such that they're responsible for different parts of the request or different parts of the protocol that we care about, but they're not entangled with the driver logic anymore. Now, the drivers are simply responsible for the platform-specific logic that they need to encode. So it's a much better separation of concerns. It's like, why didn't we do this from the beginning? Well, that's what happens when your code just kind of grows and grows. The other cool thing is that the drivers are now independent projects. You could actually just import them as node libraries and run your automation without a client at all, because they don't know anything about requests, they don't know anything about protocol, they just do automation stuff. And Microsoft has already taken advantage of this and are contributing a desktop Windows application driver in this schema, which is pretty cool. So it kind of shows the power of when you have the right abstractions and the right separation of concerns, it makes it really easy to kind of get more velocity in your project, adding new things, and that was the whole point. So I've talked a little bit about organization and modularity, but it has to be implemented in some concrete way. So that chart that I just showed you is not code, right? So what did it actually look like when it came to files and folders and modules and all of that? So I'm going to take a little interlude here and kind of share with you what was kind of floating around in our heads when we were trying to think about how to instantiate that architecture in code and files, in modules, and all the rest. Being involved in the Node.js community and being aware of what's popular on Hacker News and listening to too many conference talks, there's a lot of like buzzwords and whatnot floating around in our brains, and so that's what we're reaching for as we're trying to come up with architectural solutions. So some things that were kind of in our minds, micromodules, this concept I just spoke about, in our minds, we generally had this idea that you sort of want one module per discrete bit of functionality. That's what the whole tiny modules thing means. That's how you're supposed to use NPM and all the rest. That you should use NPM and really strict semantic versioning to manage your module relationships and dependencies. And you probably have a one-to-one relationship between modules and repos, right? It's not something we always think about, but a module is not a repo, but we just assume that there would be a one-to-one relationship between those things. We'd also heard a lot about microservices. I mean, I work at a cloud company. We have a lot of different services that talk to each other using network and whatnot. And it had been beaten into me that monoliths are bad, right? You should hate monoliths. I mean, do we really know what monolith means? No, but clearly Appium is a monolith. It's 160,000 lines of code. It's all in one place. It must be a monolith. Monoliths are bad, therefore we should break everything up, right? And we should hermetically seal off our components from each other, our internal components. And maybe they should even be talking over the network to each other using some kind of RPC or HTTP transport or whatever, instead of just being in shared memory and passing objects back and forth. So again, these aren't explanations of what these philosophies are really trying to say. This is our sort of vague understanding of them at this point in time. So what did we end up with? Well, we ended up with something like this. A lot of modules. Actually, there's even more in reality than are in this little chart. I think the exact count's like 47 or 48 separate modules for Appium. And it's beautiful, especially when you add colors. It's just fantastic. That's what we thought anyway. So going back to our Sorcerer's Apprentice analogy, we felt super satisfied with ourselves. We'd made all these little brooms that can go around and carry the water for us. We had all these little modules that were doing their respective jobs. It was great. And then we actually started to do our day-to-day work in this new architecture with these 50 different modules. And a lot of things about our new architecture was great, but working with all those modules was kind of crazy. And pretty soon we began to feel like this, right? Now all of a sudden we were drowning in the sea of our own cleverness. We had made all these modules and thought they were so cool, but it started to take up all of our time to just manage our dependencies, our internal dependencies, and manage our modules. And we were doing that more than getting actual work done. So that didn't feel right. We started to make tools to solve those problems, right? We started making programmatic ways of managing multiple repos, programmatic ways of maybe automatically updating versions of modules and like rolling cascading changes in modules and dependency updates up to the main project. But pretty soon I kind of started to wonder. I stepped back and it's like, what is this whole micromodules thing? Is it really working? Does the emperor really have any clothes on here? So we went back and asked ourselves again why we had done this in the first place. And this was a really good idea for us to do this, and I highly recommend doing this in your own projects. Why did we think micromodules or some vague general notion of microservices was the right approach for us? What did we think that they were going to give us that we needed? So we came up with this list. Well, we wanted separation of concerns. We wanted an increased test surface area. We wanted CI for each component that could run asynchronously or in parallel. We wanted to be able to version our components separately, use NPM and semantic versioning for dependency management. And we wanted to be able to release small internal modules for third-party consumption if we wanted to. This is all open source, right? So there's nothing to hide. If someone found one of our modules useful, we wanted them to be able to use it on their own. And so it needed to be its own little module. Okay, these are real benefits. And the micromodules architecture did give us these things. But it was starting to feel like it was coming at a really high cost. And we kind of identified then some of the drawbacks to this approach that we hadn't really anticipated experiencing. Working with a lot of repos is very frustrating. If you're trying to get stats for a Git repo, for example, and you're doing that over 50 different repos, you're going to go insane, or you better have some really great automation to kind of roll things up, to ignore the commits that are only sort of porting one thing from one repo to another, or syncing up repos in various ways. Even doing things like I had to do periodically for conferences, like figure out how many unique contributors do I have in the Appium project. Well, now I've got to write some script to go into each of the 50 repos, look at the log, and then deduplicate contributors and all that kind of stuff, and it was pretty clunky. I had to context switch every time I needed to work on a different part of Appium because everything was in a different module. I had to go in and set up a new terminal session, set up new tmux and vim and all the rest. Sure, it might have only taken 30 seconds, but it was 30 seconds long enough for me to forget what I was doing. And then your Git history gets clogged with commits which only serve to sync up state in your different repos, right? And that's kind of ugly and annoying. And in your top repo, you have nothing except for update this to this, update this to that, update this to this. And so you can't look at your Git and your Git log anymore in order to generate a change log for your overall application. Likewise, working with many modules is frustrating. We're using Babel and transpilation and all the rest, and so even just the time it takes to npm install one of these modules is like, on my machine, can be upwards of 3-4 minutes. And so again, if I'm switching context from one module to another, and I want to rmrf my node modules directory and npm install, just to make sure everything's working well, that's definitely enough time for me to forget what I was thinking about. That's enough time for me to go get coffee. And that's not really valuable. Making changes across multiple packages becomes very, very challenging. You might have dependent changes. You might have PRs and multiple repos that you need to merge one at a time, maybe in the right order. And you even then have to worry about lots of module level boilerplate, like package JSON, some of your build tools and whatnot. If you don't have that really cleanly factored out into some internal build module, you're going to waste a lot of time just setting up each individual module and working with it. Dependency management itself is horrible. I mean, who likes dependency management, right? And now we had 50 times more dependency management. Think about a third-party dependency like Lodash, which is a part of every one of our different modules. And they just recently went from version 3 to version 4, I think. And so we are looking at making a potentially breaking change in each of our 50 modules. I mean, that was enough for us to say, oh, we're not going to do it. Because who has a couple hours to go and test 50 different modules for that? And that's not the way that your development process should work. Even having different versions of third-party modules or even internal modules in different parts of your application can cause problems. I noticed a strange fact about JavaScript or Node or whatever that I hadn't noticed before, which is that if you do an instance of check against a class or prototype from one version of a package, it's not the same as the same class or package from same class or prototype from another version of that package. So instance of checks had to be within the same version of our modules. And so it basically meant that instance of checks were useless unless we were checking the type of a built-in type. And the same goes with per module continuous integration. It's really nice and we like it, but it doesn't actually save us any time. What we really wanted without knowing it was some kind of incremental build process where we had a build that knew our dependency graph and knew how to test all and only those things which needed to be retested based on something that had changed. And splitting it out into a ton of different modules only made that harder. Okay, so we took another hard look at the supposed benefits and asked ourselves whether we really even needed these things. So, a couple definitely we needed: separation of concerns, super important; increased test surface area, more tests. Obviously, we need those things. But what about versioning components separately? It turns out we didn't really need that for any particular reason. If anything, it made our jobs harder. And then we thought again about our desire to be able to release individual internal components for third-party use. Great idea, but at the end of the day, 90% of these things aren't going to be modules anyone is going to care about, so we're actually doing more work for no benefit. So, we thought we wanted these things because that's what we heard was right, but it turned out that we didn't maybe really need these things. So then we asked ourselves whether the micromodules philosophy was really the best way of getting what we actually wanted, or the only way of getting what we wanted. And it's pretty obvious, I think, at this point where I'm going, and I don't think that it is. So, step back a minute and ask what happened. Is the Appium team just a bunch of yahoos and we don't really know what we're doing? Maybe, but I like to think that we're reasonably good developers and we've had a lot of success. So why did we go down this path to begin with? We've been working on this project for years. We knew it inside and out. How did we get stuck with this architectural direction that turned out to be a poor choice? Well, we made a bunch of assumptions. First of all, we had this kind of one module to one repo correspondence idea, which is not a given anymore. We thought that because we were an open source project, internally we should follow the kind of open source model of getting work done. And what I mean by the open source model here is, lots of individual actors making small, useful packages that everyone can then use and kind of mix and match in their own projects. And that's really great in the kind of general open source ecosystem. But Appium is not the general open source ecosystem. Appium is one thing trying to solve one problem. And the kind of analogy didn't really port over as well as we thought it did. We also kind of had this weird mashup of micromodules and microservices in our brains because they do resemble each other in a lot of ways, even though they're completely different concepts. And we sort of went in the direction of even a microservice architecture without understanding why it didn't apply in our case at all. I think we were fooled particularly because we had internal components that did RPC with each other. They did speak over the network to each other, and that's how they worked. But at the same time, at the end of the day, Appium is one process or one app living in one memory space. And we didn't need to scale its internal components horizontally for reliability or whatever. In other words, Appium was already the one service that it needed to be. We didn't need more services within it. So, superficially it seemed like we needed micromodules or microservices, but we actually didn't. So I think what happened is that we, very subtly slid into the trap of cargo cult engineering. And if you're not familiar with this concept of cargo cult engineering, it comes from a really interesting phenomenon that anthropologists have studied. They discovered it in Melanesia, for example, Papua New Guinea, back around the time of the World Wars. And there's a lot of literature on it, and I'm going to tell you a very simplistic story, but basically, you have pre-technological civilizations on these islands that begin to encounter technological civilizations in the form of, ships, aircraft carriers, airplanes, and all the rest. And these ships and planes would come bearing various kinds of goods, food, even like magical implementations, radios and whatnot. So the people kind of assumed that it was the ships and the planes that were the originators of these goods. And so they developed sort of cults or religions sort of calling on the deities of the ships or the planes. And this picture is like a wicker basket version of a plane, kind of, I guess, designed to focus the plane deity on it and to drop down some parachutes of goods or whatever. So the connection with engineering is this, sometimes we see a practice that delivers some amazing benefit, or we see a tool that delivers some amazing benefit. And so we adopt it ourselves without fundamentally knowing why it works, how it works, or whether it even applies to our situation. And as long as it doesn't completely destroy our development process, we might keep it. We might think that it somehow matters because honestly, we don't know. And in doing so, we're misascribing efficacy to this magical component when in fact the real reason it's working is something else. And so it attains the status of a ritual. At the end of the day, we have this little thing in our system because that's just the way we do it. And that's really dangerous because you kind of lose control, you lose the ability to actually engineer your system correctly. But it's not always an easy trap to avoid. So then, revisiting these concepts, without sort of the cargo cult mentality of, well, they're going to solve all my problems, and I don't need to totally understand what they do. We can talk about what microservices, the philosophy actually is. Essentially it's a way of solving problems that you have in scaling systems reliably and maintainably by breaking a very large and complicated application into multiple independently running services. So, in what kind of situations would you actually need something like this? Well, maybe you need to distribute processing or data across a lot of machines or VMs or containers because one isn't good enough. It's falling over, you're out of memory or whatever. If your app has conceptually a lot of distinct responsibilities, but they can feasibly be broken up into different services along lines that you already know. Your services, of course, have to be able to do their job behind load balancers or you can't scale them horizontally. Maybe you want fault tolerance so that a particular instance of a service can go down while not affecting user experience. You're not constantly changing your application across multiple services. And the last point here is the most important, that all of the above is so important that you want to deal with a huge increase in the complexity of your application because that's the cost of dealing with microservices and orchestrating all of that. So, obviously we didn't need any of this. Well, what about micromodules? When do you actually want all of these tiny small modules? Well, if you want each module to be npm installable on its own for whatever reason, of course you have to have different modules. You of course need to religiously follow semantic versioning or you're going to go insane. You probably want a module if you have a genuinely useful standalone piece of software that other people will use. For internal stuff, there's no reason to have single leaf nodes in your dependency tree. If you have a module that's only depended on by one other module, there's no reason for it to be out there on its own. Put in a different folder or something inside the parent module. A lot of people think that the micromodules philosophy is great for encouraging, a README for a small chunk of functionality, more tests, more continuous integration, better separation of concerns, and that's true. It does encourage all of those things, but it's not the only thing that encourages all of those things, and you don't need micromodules to do all of those good things. So what about micro-repos? This idea that you want a bunch of small repos as part of your project. When would you actually want to do this? Well, I could think of actually one reason, which is that you want different communities of people to be managing different parts of your application. If you really want different issue trackers and all of that, then go for it. But that's about the only reason I can think of after going through this process. And something that you may have heard about more recently is the concept of a monorepo. Projects like Babel do this now. They have many different modules as part of Babel, but they're actually still all in one repo for some of the reasons I mentioned earlier. And just because you have a monorepo doesn't mean that your application is monolithic. And that's something that's not always easy to see. So I tried to distill some of this into sort of a chart of examples. The main idea here is that I'm trying to show how microservices, micromodules, and microrepos are different concepts and totally orthogonal to each other. And in principle, they could vary with respect to each other in all dimensions. In practice, some of them tend to go together. But so if you have a cloud platform or a huge SaaS app or a huge website that has millions of hits a day, do you need microservices? Well, maybe you do, just to kind of handle that kind of scale and to be able to allow big teams to work on it separately. Do you need micromodules? Well, we probably want one per service, and maybe if you have shared utilities, you want one or a couple for that. Do you need a lot of repos? No, you don't. You could choose to do that, but you may not actually need that. If you're doing something like a desktop app or a web app that doesn't need to scale to millions of users, really you don't need any of these things. Just organize your code well and you'll be fine. Are you doing an open source library with lots of individually useful components, something like Babel or Lodash or whatever? Well, you don't need microservices because you're not running any services to begin with. You might want a bunch of modules so that people can pull down individually useful components out of your overall library. But again, you may not, and I would argue probably don't want a million different repos because that's going to make your life a living hell. So back to Appium, we may not have understood what we were doing when we went down the path that we did, at least not as well as we understand it now, but certainly wasn't all bad. We learned a ton, learned a lot about NPM, managing modules, built a bunch of useful tools for a module and repo management. Actually going through this micromodules transition forced us to split up our app in good ways, which even if we were to pull it back together, we would keep them modularized in the ways that we've done because of this. We've learned a lot more about our problem space. The whole ES 2015 transition went really well, and we're big fans of that. And we've got a lot more tests, a lot more READMEs, a lot more CI, and everything. So it's kind of the end of the story. What are some final takeaways that might be useful for other people who are contemplating a rewrite of a big app? Definitely do the ES 2015 thing. Transpilation is worth it. Or I should say, the language features are worth the transpilation. Beware of cargo cult engineering. Try and develop a sense of when you might be doing things that you don't understand just because they seem magical and useful. By the same token, adopting a stance of suspicion towards trends and buzzwords is, usually a pretty good way to do things. Before you think about microservices or micromodules, make sure you deeply understand the problem space of your app, how you need to split it up. Otherwise, you're going to split it up along the wrong lines, and you're going to be in a bad position of having to make changes across really large boundaries. Make sure that you have a nice distinction between your internal dependencies and external third-party dependencies. If you can help it, don't rely on leftpad. If you guys remember leftpad from a couple weeks ago. And microservices and micromodules are definitely not identical with and aren't even a substitute for just good programming practices, right? So if you're a mature software engineer, you're going to write code that's modular. You're going to separate concerns. You're going to constantly be refactoring. You're going to write documentation. You're going to write READMEs on a per folder level, not just a per project level. You're going to write testable code. You're going to write a lot of tests and all the rest. So that's actually what's going to help you, not tons of tiny modules and things like that. That can be a tool that you can then take up if you're particularly in need of it. But the main thing is just to follow good software development practices. But what I will say is that I think maybe, as is borne out by our story, at the end of the day, it's probably only possible to tell whether an architecture is right for you by at least diving in a little bit and trying it out and seeing how it goes. It was really good for us to feel the pain of having to make all these changes, to know that we had chosen the wrong architecture, right in many ways, but wrong in some ways. And we had to kind of go through that process in order to discover that. And I'm guessing that that's going to be the same for a lot of applications. So in terms of Appium's future, this is kind of where we've ended up as the new the new architecture. It's a lot more reasonable. We're keeping a couple things distinct because we actually want different open source communities to be working on them. But otherwise, it's a lot easier to get your head around this, and hopefully it will work better for us moving forward. A couple of resources if you want to read up more on some of the things I talked about here. I'm sure the slides will be shared, so you'll be able to click on these links if you download the PDF later. And yeah, good luck with your own re-architectures, and that's the end. Thanks. Do we have time for questions? Cool. And this gentleman here has a microphone, so if you do want to ask questions, put your hand up and he'll come by. Nothing. All right. Oh, we have one.
So you mentioned that a module is only a good idea to consider splitting it out if it could conceivably be useful outside of the context of your original app. And I was curious sort of what your criteria was for that. How can you tell if something is more broadly useful than just within your app? I
mean, I don't know if there's a real objective criteria. I think you just got to imagine, like, if I'm someone else, would this be interesting? Would this be useful? So like an example for us of something we thought was useful, we had a library or a module that was responsible for changing plist files inside of the iOS simulator to kind of tweak its behavior when you ran it. And we thought, you know, someone else who might not even be doing automation, they might be doing something completely different, might use this as part of a command line tool to change the behavior of the iOS simulator. So, you know, we went ahead and did that. I think another situation where you do want a separate module is if you have something internally that's depended on by two other internal things. Like in that case, you do kind of need a separate module as well. But in the first case, it's really just a judgment call. If you're an open source project anyway, you might find somebody using it on its own, and then that would be a good signal that you could then pull it out and make it its own module too. Thanks. Any more questions? All right, thanks for listening, everyone.